Hello, Avengers. This is Coach Shafto. Today we're working on the Carnegie book, page M3.108 to M3.111. In this lesson, you will learn how to solve equations using a bar model. You will need to complete all of the questions, and other assignments can be found on Google Classroom. On page M3.108, it starts with a warm-up, and it asks us to consider the number 0 and what comes to mind. It says to write 5 different numeric expressions for the number 0. So I'm going to do that. So the first example, we could say that for the first example, we could say that 2 minus 2 is equal to 0. On another example, we could say that 5 plus 1 minus 6 is equal to 0. We could do another example and say that 0 times 4 or 5 is equal to 0. And if we get more creative, we can remember that, I can use variables as well. So we could say x minus x equals 0, because anything minus itself is 0. We could also say something like 0 times m is equal to 0, or for example, 0 divided by m is equal to 0, because nothing divided by anything is still nothing. Alternatively, we could get even more creative. We could say 0 times everything inside this parentheses is still going to be equal to 0. You should come up with your own here. On question 2, it says, did you and your classmates use common strategies to write your expression? How many possible numeric expressions could you write? And so really, if we were looking at this, we could write as many as we wanted. So there are infinite expressions. We could go on and on and on forever doing this, which is why we are now going to stop. On the next page, we are on Carnegie 2.1. It gives some reasoning about addition equations. And it tells us that when we're using addition, we can use this thing called a bar model. And you've done these in elementary school, but now we're putting variables into them. And so the example tells us if we had x plus 10 equals 15, we could write that in green here as x plus 10, and then we have 15, and those are the same because there's an equal sign. Then if we go down, we could break it up into 2 different parts. So we have an x and a 10, and then we have our original green section. And then on the bottom, we break it up to say, this 15 could break up into the 10 and the 10 match up, and then this x matches up with whatever the 5 is. So then that tells me that x is equal to 5. On the next page, we're going to work some problems. And it says, why is the number 15 decomposed into the expression 5 and 10? And this should be pretty obvious because 5 plus 10 is equal to 15. So it's just a different way of writing the same number. In question 2, it says, describe how the model in the worked example would be different for each equation. Here in this example, we could set this up, and we could say that we have x plus 10 equals 17, and then I have x plus 10 and 17. So this is my equation. We broke down the equation into 2 parts here, and then down at the bottom, let's break it down. This is still going to stay as 10. And then over here, what plus 10 makes 17? To make this true, we need to make this into 7. And so we know that x is equal to 7 because 7 and 10 make 17, and these x and the 7s match up. In this next section, again, we're breaking it down, trying to figure out how to do this. We have the x in this box. I should put the 6 because that's the other part. And so I go straight down, and there should be a 6 here. And so I have to figure out what plus 6 makes 15. And so we know that we could subtract 15 minus 6, and we get a 9 here, because 9 plus 6 equals 15. And so this tells me that x is equal to 9. If we go down, it says complete the bar model. In the first section, I'm going to put 14, and then I'm going to put x in the next section. Down here, I take the 14 straight down, and I'm going to put 14 again. So I have to figure out 14 matched up with what number makes 32. And so I can subtract. I can take 32 minus 14, and that's going to be equal to 32 minus 14 is going to give me 32 minus 10 is 22, and then 22 minus 4 is 18. And so right here, this is 18. X is equal to 18. And it says write the equation represented by the decomposed expressions. What that's asking is it's asking you to go ahead and write the expression that is shown right here. So we could write simply 14 plus x is equal to 32. And it says which value for x makes the equation a true statement. And we already solved this, and we said that x was equal to 18. If we go to the next page, it said consider this equation. 90 is equal to x plus 64. And so we need to set up the whole thing. So in this section, I'm going to put 90, or I'm going to put x plus 64. So in this section, I'm going to put x plus 64. And then the bottom section, I'm going to put 90. Then up here, I'm going to put x. And in the second box, I'm going to put 64. And down at the bottom, my 64 will stay the same. It goes straight down. But then I have to figure out what is this x going to be. And I can do that by subtracting, because I have this 90 and part of the 90 is 64. So I do 90 minus 64. And that's going to be equal to 90 minus 60, which is 30. And then 30 minus 4 is 26. So over here, I've got 26. And so this tells me that x is equal to 26. If I scroll down, it says write the expression represented by the decomposed expressions in the bar model. So this is x plus 64 is equal to 90. Alternatively, you could also write 26 plus 64 is equal to 90. And then which value for x makes the equation true? We know that x is equal to 26. In question 5, it says, in each bar model, how did you determine how to decompose the given expressions? And basically, we just subtracted the whole minus the part is equal to the other part. Remember that you need to complete all of the questions in this section, and that you can find other assignments on Google Classroom.